Our very first topic for college algebra is going to be the distance formula. This should be a review. When we give formulas in this class, I will try to explain where they come from, even though you will not need to recreate a proof on the test. I think it helps you understand why the formulas work the way that they do. So we're going to start with the distance formula. And this starts with the Pythagorean theorem, which I know you've seen a million times. So we've got a right triangle with A, B, and C, and the Pythagorean theorem says that A squared plus B squared equals C squared. Okay, so you have the two legs, the hypotenuse is always across from the right angle. So that's the Pythagorean theorem. I know you've seen that a million times. All right, so we're going to use that to find the distance between any 2 points. So let's say we have a point. We'll call this one x1, y1. And we'll call this one x2, y2. And we want to find the distance between them. So any 2 points can be imagined as, if they're not exactly horizontal or vertical, you can just count that out. Otherwise, any 2 points can be imagined as a right triangle, where you have the horizontal distance and the vertical distance. So the horizontal distance from here to here is the distance between the x's. So we could write that as x2 minus x1. And then the distance between the y's, or the vertical distance would be the distance between the y's, and that would be y2 minus y1. And if you look at this, we've got a right triangle just like we had above. Our 2 legs are our x's and y's, and distance is the hypotenuse. So we would have x2 minus x1 squared and y2 minus y1 squared, and that's going to be equal to the hypotenuse squared, which is d. Okay, so we've got this. It looks massive and complicated and a mess, but it's really just the Pythagorean theorem. And since we're usually using this to find d, we're going to go ahead and take the square root on both sides. And we're going to rewrite this out. x2 minus x1 squared, y2 minus y1 squared. And when we take a square root of something squared, the square and the square root cancel, and we're just left with d. So we get the square root of this big whole thing, and that's our distance formula. Okay, so it looks big, it looks messy, but it's really just the Pythagorean theorem. And you just need to be careful when you put these in, that you're careful with the signs especially, and you follow the order of operations. We cannot distribute a square root over addition or subtraction, so there is no simplification of this formula. If I could break this up and cancel out the square roots, I absolutely would, but you can't do that. You've got to follow order of operations, so you've got to do parentheses, then exponents, then the addition under here, and then finally the outer function. Okay, so let's look at an example. Let's say we want to find the distance between 2 points. Let's say we've got -1, 3 and 2, -3. Okay, so you're going to name one of them x1, y1, one of them x2, y2, and it really doesn't matter which one you name which as long as you stick with it. You don't want to mix your x's and your y's. Okay, and we're going to do distance equals, and I'm going to do x2 minus x1, so I've got 2 minus -1 squared, and I've got y2 minus y1, so it's going to be -3 minus 3 squared. Okay, this is where you got to be careful on your signs. So 2 minus -1, remember minus minus is the same as plus plus, so that's going to be 2 plus 1, which is 3 squared, so that's 9. This one is going to be -6 squared. -6 squared is going to come out positive, and that's going to be 36. And we get the square root of 45. Now, most of the time in this class, when you have a square root, you're just going to be putting it in the calculator. So for the most part, you don't need to worry too much about simplifying square roots. Unless it's your final answer and it's going into my math lab, they are going to require you to simplify this. If you can't put it in as a decimal. So just to remember how to simplify these square roots, you want to try to break it into 2 factors that you can take the square root of. So for example, 45, I could break it up as 3 times 15, but that doesn't do me any good because I can't take the square root of either of those. I could also break it up as 9 and 5, and that does help me because I can take the square root of 9. So you're looking for factors that you can take the square root of. I can break this up as 9 times 5. 9 I can take the square root of, and I get 3 square root of 5, and that's my final answer. Okay, so again, I'm not too picky on this. Most of the time we'll just be using this as a decimal when we graph and stuff like that, but if you are putting this into MyMathLab, they are going to require this for your final answer most of the time.